I think we can get started. Okay. So, cool. Hello, everyone. Today's session is about Azure SQL Database, the database of choice, and we have Sanjay Mishra as our guest speaker. We'll be going through the agenda next, and we'll see what's up for today. We'll be doing introductions of the host and speaker. We'll be sharing the mission and vision of Women Who Code, a little bit about the speaker as well, and then about the session. We also have Q&A time in between the session and also at the end. So feel free if you have any questions to drop in question and answer or in the chat session, and we'll be happy to answer. So let's get started. You can start putting where you are joining from, let us know, and excited for this. So this is our panel for today. I'm host, I'm Aarti Dalvi. I'm lead volunteer with Women Who Code. And I'm so sorry. So we have our speaker, Sanjay Mishra. He is Principal Group PM Manager at Microsoft. At Women Who Code, our mission is to inspire women to excel in technology careers. This is the code of conduct. Women Who Code is an inclusive community dedicated to providing an empowering experience for everyone who participates in or supports our community, regardless of gender, gender identity and expression, sexual orientation, ability, physical appearance, body size, race, ethnicity, age, religion, socioeconomic status, caste, creed, political affiliation, or preferred programming languages. Our community is spread over 20 countries and 60 cities with more than 167,000 members. We have more track communities which run online like data science, Python, blockchain, mobile, front end. So let's get started with the session. I'll stop sharing my screen. Sanjay, are you ready?
Yes, thank you, Aarti. I'll share my screen, and as soon as that works, it's good. Welcome, everyone, and I'm very honored to be here with you, talking about a topic that is very close to me, and it is Azure SQL Database. Can you see my screen?
Yes,
and you can see my PowerPoint in presentation mode?
Yes, I can.
Awesome. Thank you again. And today we're going to talk about Azure SQL Database. It's a database in the cloud, and which you can use for a variety of your application. We'll take several examples to walk through them. My name is Sanjay Mishra, and I'm a Group PM Manager in the Azure SQL team in Microsoft. In my job, I get to talk to many customers almost every single day, understanding what the requirements are, what they're trying to build applications with, what kind of business requirement they are bringing in, what kind of requirements they're putting on our product. And they come up with a lot of stuff. They come with their story. They come up with what their customers are asking from them. And in this discussion, I hear a lot of stuff. What I don't hear is a few things. What I don't hear from customers is that my data is not growing. In fact, hardly anybody says that. The reality is that 90% of all data in the world was created in the last 2 years. And you can see how fast this data growth is happening right in front of our eyes every single day, every single moment. What I also don't hear from them is that data is easy to consume because data comes in so varieties that consumption patterns are also so different and varied and also evolving all the time. Hardly anybody says that my data is easy to consume. In fact, 73% of data is not being analyzed either because it is hard to access data, hard to get the data in the right structure and format, and hard to connect between the data and the consumption tool. And I also do not hear from customers is that, well, I don't have new business needs to consume data in many different ways. In fact, the business needs are evolving so fast new applications are being created. The reality is that 500 million apps will be created in the next 5 years. And some of those apps will be completely varied from all different aspects of life and society. So for example, let's talk about some of the applications. And let's talk about soccer. It's awesome to see small kids playing soccer on a field, which we don't get to see now because of the pandemic. But how about a professional speaker? Let me take you to a window where I can actually show you professional sports being played. A video of a Women's World Cup, 1999 Women's World Cup. Some of you who have been watching soccer for a while and have been a soccer fan may remember this. Sorry, the video is not very high quality. This is 1999. This is more than 20 years old. This is the final was played between China and USA. The final, during the time of the play time, they could not decide. It was 0-0. So the match was decided based on penalty kicks. And you can imagine, this is a World Cup final between two big countries, lots of fans involved, and match has gone to the wire. And in fact, it was 5-4, the penalty, the results I can tell you 5-4. So you can see how close the match was. Millions of people watching all over the place. And I'll show you a video. The video is not very high quality, my apologies, but you can see what happens in next few seconds. The player is ready to kick and see what happening. So that was 3 seconds of video. In these 3 seconds, what is happening is the player is kicking the ball, the goalkeeper is diving. As you probably know in soccer, in penalty kicks, the goalkeeper takes a bet. They in their mind, they toss a coin. I'm going to dive left or dive right. They do dive on one side. If they're lucky, ball also comes on their side. They may be able to save the ball. The goal happens. Everything happening fast. And some places, they do spot betting. Within sport, they do spot betting. On this spot of the moment, they can do betting. There will be, there are places which allows spot betting. The people will be putting bets on many different things, including which side will the goalkeeper dive? Is it going to be a goal? Is it going to be saved? All happening in real time. Millions of people connected and betting their money. And by the time the goal is scored, the kicker is going back to celebrate with her teammates. The people who had actually put their bet on, they have got the money paid back to them. So it's all happening so fast at such a high concurrency. And guess what? This is a matter of money. So you cannot lose any data. You cannot lose any transactions. You cannot have a transaction that says, okay, eventually I'll make everything consistent. Everything has to be transactionally consistent because somebody may have put a bet on $1, may claim after if their condition of the betting has been successful, they will say, I have bet $1 million because you have lost their record. There's such a high pressure, high financial stakes. But there are other situations when the stakes are even higher, like life. This is a picture of an assisted care facility. I don't have a video, but what happens here is that people who are being cared for here are in a health state, they cannot take care of themselves. The nurses are there taking care of the patients, administering medicines at the right time, at the right dose, right quantity. It is so important to administer this medication because some of these medications are very high powerful, and they can have side effects if not administered on time or at the right dose. And the data is being recorded in a database because if there is a shift change, the nurse goes and another nurse comes, and they do not see medicine has been administered, they may administer the medicine again. Underdose or overdose can cause life risk. It can be fatal. So in these kind of situations, you want a database that you can rely on for the life. So when you're building applications for this kind of database, what kind of database you need? These kind of applications need databases that can super fast in response. strong transactional consistency. They may need high concurrency, as in the soccer game. They need highly reliability, highly available. You don't want any kind of disruptions. They have to be secure. After all, we are talking about healthcare. We are talking about financial transactions. That could be large data volume, that could be small data volume, does not matter. You need great price performance. Everybody cares about price. Everybody cares about cost optimization. And of course, we are talking to people who write code here, which means that the database better be developer friendly and easy to deploy, manage, and many, many, many more things. If these are your requirements, then your database of choice is Azure SQL Database. It's a database built in cloud, built for cloud developers, for modern cloud applications. Some of you may be familiar about what a cloud database is, but I'll give a 1 minute introduction to it. What happens is that if you have a database on premises, you are taking care of the hardware, how do I purchase, where do I install it, taking care of backups of your data, set up high availabilities, make sure that it is compliant, make sure it is secured, physically secured, as well as accessibility secured. You have to monitor it, you have to apply the patches, you have to apply the upgrades, all that stuff that you have to do. What we do in the cloud is that we do all these things built in for you, so that we take care of the database chores, so that you can take care of application, whether it is a soccer game, whether it is a healthcare facility, whether it is a stock transaction, whether it is about education or anything. And what we call this, we call it a platform as a service. In the database world, we call also the database as a service. So that's what is cloud database is. So what we have done in SQL Server, we have taken the SQL Server that you may be familiar with. That's a pretty established rock-solid database run on premises. We have taken that database and put it in the cloud to make it available to all cloud users. It's the most matured PaaS service on Azure, and it's also serving since 2010 based on SQL Server Engine, as I talked about. It's in fact is the most matured cloud database service across any cloud. You pick up any cloud, you pick up any database, this is the most mature database service you can find anywhere. As a price performance leader for all database workloads, we have actually published benchmarks on price and performance publicly. You can avail them. It's also the highest availability backed by financial SLA across the industry, and the best security and best compliance that you can find anywhere. Flexible deployment choices, you can just deploy a database, you can deploy an instance, you can deploy them in pools, you can deploy them in serverless mode, in hyperscale mode. We'll take some examples and some demos here for you to verify or get a deeper understanding. And no matter, since we have all those capabilities, this is so popular, and more than 6 million of such databases are running today. The journey started in 2009 when a single SQL database in Azure could be 10 gig. And in 10 years time, we have taken it by leaps and bounds, and we have made a single database can be 10,000 times. Now you can actually provision a single SQL database, 100 terabytes. And we'll see some examples. So how do you use SQL database? You can use Azure SQL database in many different ways, in many different types of applications, because it provides many developer-friendly things. You can write things in JSON, you can have change tracking, you can actually write graphs, you can write special queries, you can use memory optimized things, you can see column store, which is disk optimized structures. All these in a highly secured and highly available environment. I'll also provide you a link with where a colleague of mine wrote an article, 10 reasons why to use Azure SQL for your next project. And guess what? You want to build all this stuff with a peace of mind, because you don't want to wake up in the middle of the night saying that, oh, my database is down, because we have provided built-in redundancy within zone, across zones, across geographies. And all this redundancy leads to 99.995% uptime, and it is backed by financial commitments. Linked for the details of this. It's not just highly available and highly up, it is also completely secure. It provides the enterprise grade security that you can put any types of application and then have a sleep well at night, saying that my database is being protected, whether it is from network perspective, whether it is from threat protection, the physical security, or any kind of access management. A customer data is always protected. And no wonder SQL Server is known to be the database with the least vulnerabilities. And you can see how other databases, that higher the number here, the worse it is, because these are vulnerabilities in last 8 years or 10 years time frame. So let's see all these things in action. And what we'll see today is actually a demo of an IoT workload. This is a smart grid power meter where the power meter at every residence, at every business is installed. They're smart in the sense that they have IoT device installed on them. They will read the meter from the electric meter and send it to a central database. I know that people from all over the world joining this call today. Here is a map of the area where I live in, close to Seattle. And this is a map showing the location of some of the power meters where the data is sending it to you. So we will move to a demo where I am actually going to show how can I scale these hundreds and hundreds of power meters and thousands of power meters sending their data to the database. Can that database keep up? And we will see it here. Okay, right now nothing is running, and what I'm going to do is that I got an application which will actually simulate power meters, and then they will start sending through the data, and you'll see how many data, each row of data represents a reading from the power meter, and you'll see how many of them are coming. It will show that in a chart. You can see that instantaneously it can scale to 1 million, 2 million, it'll go beyond 3 million, and all this stuff. And that's how high concurrent this database is. And now guess what? Now we're going to check. This is a query that tells me how the resources are being used. You can see that we are at 0. Every 5 seconds I get a time slice of this resource representation. And you can see that we bumped up from 84. We are going even 93. That means I still have some headroom while I'm ingesting more than 3 million rows per second. You take that into account. While the meter readings are coming in, you may have a business person who is looking to see, okay, I want to know, let's say there is a storm, there is a weather related event, or there is a power outage in some area. You want to see, am I getting power readers from all my consumers, from all my covered areas? Then they want to run some queries. They could run queries on this data real time to find out any information they want to find out. And guess what? What we have done is that because we have built in the redundancy we have built in, which means that we have multiple copies of the data behind the scene to protect this database for high availability. What we do is that we actually expose one of those copies for you to run queries. And that we will run in another window. I want to run a bunch of queries to find out, am I getting meter readings properly? Am I getting read from this zip code? Am I getting reads from this town? I'm going to read from this set of meters. You can run all types of queries. And that's also a similar application which will kick off queries on the read database. And you can see thousands and thousands of queries also running at the same time while you are ingesting data at a very, very high rate. All these scales are possible in Azure SQL Database, and it can scale to the degree that you can need. This is all happening on one single database. So you can imagine if you need more scale, you definitely can deploy it across many databases and higher scale. This is not one of our biggest SKUs. By SKU, I mean how powerful the unit is, how much memory, how much processing power, how much of resources I have provided to the database. This is not one of our biggest. You can scale even higher than this. So that's the IoT type of scaling that you saw. The IoT data comes in JSON format, which is actually converted into relational format and put into the database store by stored procedures. Okay, going back to our presentation. Now you could see that, okay, how about my application has all other kind of complex data types, complex usage pattern. How about if I want to use JSON in my database? Okay, we can deal with that. How about if I want to have a graph inside my database because I have lots of data which have relation to each other. I want to find out unique things from finding the various kind of relationship among various components inside my database. You could do that. Or you could see how about I want to draw some geospatial information. I want to find out geography information. I want to find distance between two places in my data. Is it all possible? We have actually put all this together in one demo for you, and let's see that. Okay. Some of you may be familiar with a website called Yelp. Yelp is a place where it allows people to put a review rating for the businesses they make use of. And Yelp has actually gone and made that data set available. They have obfuscated the data. Nobody can be identified, either a user or a business. They have replaced them with GUIDs, but make this data available to everybody. Anybody can download them for educational or for academic purpose. And so we got this downloaded, and you can see there is a humongous amount of data. And then we have put together a project for you in GitHub, where you can actually play with this data. You can download the data, you download the code from here, you can play with them. I'm going to showcase you a few use cases that we will use this data for. This data is actually that comes in JSON format. When you download all those data, that come in the format of a set of JSON files. And you can actually, this example shows how you can actually convert the JSON file through a function called OpenJSON. It opens the file, takes every single JSON object, and then can actually convert it into regular relational format and puts it into the table. Once it is in the table, the whole power of SQL database comes into the picture, and then you can deal with them. What I have put together here is a few use cases where we will see many interesting information that you can find. For example, we'll talk about some graph algorithms. As you can think about, because this data has information about people, information about businesses, the same people may be going to the same grocery store, same people may be going to the same restaurant. So there is a connectivity among all the people. What I'm trying to find out is user number one, identified by this GUID, and user number two, are they connected in some way? And here is a graph query, which is going to try to find out if they're connected in many different ways, which is called friends. In graph terminology, they're called, are they friends? If they're friends, this query will tell us if they're friends. And if they're friends, they may be connected in many different ways. They may be connected through A and B, and because they all go to the probably same grocery store. They may also be connected to C and D because their kids go to the same school. Many different ways. So we'll find out if these two people are connected, and we'll execute the query. Now, while the query is executing, I'm going to talk about what this query is. This query is a very brute force method. It is trying to see, am I connected to, is A connected to B, user one connected to user two through one hop, or is connected through two hops, or connected through three hops. So this is a very brute force method. In SQL terminology, it is doing multiple shift joins and then doing union alls. This query is not very efficient. Even though you can do it, if the data set was smaller, this will come back quicker. So we're going to kill this query. What we have done is that we figured out that a lot of people are trying to run this type of queries in Azure SQL Database. So what we introduced is a people familiar with graph algorithms will know an algorithm called shortest path. So we actually implemented a built-in function for shortest path within Azure SQL. It's also available in on-prem SQL Server 2019 and later. And that shortest path algorithm is implemented within SQL as a built-in, which means that you are able to run these queries much faster. And we'll find out if they're related. Tell me, give me the shortest path. And the query is shorter, the query is more elegant, and query is much more efficient too. What we're doing here is asking, find me the shortest path between person 1 and person 2, EC. In 6 seconds, this query comes back in 6 seconds and tells us that yes, these two are connected and there is a one hop between them. So that's good. That's a one useful piece of information. But I want to more. I want to find out more. This has information about the many businesses and the geographies they are located in. There is the geographical coordinate between for these businesses. My goal is to find out if I want to go to a place and I want to find out information about this place in terms of if there is a special query. Yes. If there is, I want to go to a certain place and I want to find out information about this particular place. For example, what I'm going to do, I'm going to go watch a American football game, not the soccer that I showed, is American football game. This actually it happened in past. And I want to find out, is there a food related business close to the stadium? The stadium was where the game was played, was University of Phoenix Stadium. Actually, this is the Super Bowl a few years back when our nearest team, Seahawks, was also playing in the Super Bowl. So this game was interesting. It's being played in Phoenix Stadium, also known as State Farm Stadium. And I want to find out, this is the geography, this is the coordinates of the stadium. I want to find out if there is a food related, because I don't want to go to watch the game hungry, or if the game is over, I'm hungry, I want to go find some food. So, okay, so we will find out, let's say, in the 5-mile distance, I'm converting the metrics to the miles. So you can see that conversion here. And I'm saying that less than 5-mile geolocation distance, tell me all the food related places. And so this is running this is building a geospatial among all the businesses and telling me that, yep, don't worry, I'm restricting my output to top 10. So I see only top 10. That means I'm very happy that there are at least 10 places where I can find some food which is good. And they're all 5 stars, so why not? Pretty good. This also actually gives me an output of in a geos format. So basically, you can, if you're building a mobile application, you can actually take them and project that on the phone. Let me try to zoom it, because this itself is, and you can see that these dots are actually what my my query found. These dots are actually the location of the restaurants, which means that I do have restaurants. I'm not going to stay hungry either if I want to eat before or after. But I don't live in Phoenix. I live in Seattle. So which means that I have to go to Phoenix and stay in the hotel in a night before that, which means that I have to find a hotel as well. So I have another query. I'm trying to find out, give me a hotel nearby. So all I'm doing is the same query, except that instead of food, I'm looking for hotels. So if you see, same query, 5 miles, and then I'm going to, instead of food, I'm just doing hotels. And let's see if there are hotels around. And yes, and again, I'm restricted to 10. So I'm saying 10 hotels around, which is awesome. I'm a member of Marriott, so I would like to stay in a Marriott property. And I love Residence Inn. I find that, yeah, there is a Residence Inn nearby. And again, you can see the result in a special representation as well. So good. But I do not know how good this Residence Inn is. I've never been there. I've never stayed in it. I would like if any of my connections have stayed there and left a comment. So I have access to this. Good that I have loaded my Yelp database there, and I'll be able to see if anybody who is connected to me through Graph. So I'm using Graph to find a connection, and I'm using Special to find out a location of the hotel. And then I'm going to check if they have left a review. If anybody from my connection has left a review, that satisfies me that, yeah, I'm okay to stay in the hotel. That's my condition. Now I'm going to build a very complex query where I'm going to find out, even if there is a single, so top one, one review is good enough for me. And if this person is connected to me and has stayed in the hotel. So let's run the query. So as you can imagine, this is a pretty complex query, combining Special, combining graph characteristics to connect me. I'm the user. If any of my friends have stayed in this hotel property. As you can imagine, this is a pretty complex query. There are 8 million reviews. There are 20+ thousand businesses. So it can take a long time. And which means that I decide to give more resources to run this query. Now let's check how resourceful this database is. This is a query that can tell me the resources for databases, and this is a representation of the database resource capabilities. The two means at the end, two means there are two CPU cores serving this database. And you can imagine all those things that I was showing you on the graph, on the hotel search, on the food search, was all happening with just two cores. Now I have increased the complexity of my query, and I realized that two cores are not good enough for my super complex query. How about I give more power to the database? How would I make it 16 core? So we'll do it 16 core. And this command gives it 16 cores. This is asynchronous command. Behind the scene, it is actually taking my database and putting it on a 16 core machine. If you are on premises, you have to first go find, where can I find 16 cores? Which of my servers have 16 core machine? Either move this database or take a backup of this database, find space for the size of this database on that particular machine, which is 16 cores free, load it there and then run. While you're doing this, you are disrupting everybody else who was using the database. Thanks to the platform as a service, thanks to the cloud database service that we have, this is happening online behind the scene for you, and it's happening pretty quick. You can see it takes a few seconds. So first time we run, it's still not done yet. It will probably take a few more seconds, and it will be done to 16 seconds in 16 CPUs in pretty quick time. One more. Let's give it one more. Let's see. This is probably the final step. That's why the query is taking a bit. Okay, so it's 16 CPUs now. Now the database has more power, more processing power, and it can execute my query faster. So you'll see that while it is coming up, let's talk a bit about the query. It first built my graph, taking me as a starting node. And it used the same sorted path that we talked previously, finding any sorted path to any person who has left a review in the review database for this business. And it should come back pretty quick time. Come on. 32 seconds. So you can see that such a complex query with such a huge data set behind it, and I can resize my database at will as soon as I need it, and then it returns the query. Now I am very satisfied that somebody in my friend's connection actually stayed and left a review for this hotel. So I'm very happy. Now I can go and watch the Super Bowl in in the Phoenix Stadium. Cool. So that's how all the complex stuff that you can do on your database. By the way, after I run my query, I don't want to pay for 16 cores. I want to convert it to 2 core back, which will be also done in 15-16 seconds, and then we are good. So that's what we saw about the combining JSON, graph, geospatial all in one. I'll pause for a second and see if there are any questions. Looks like there are a couple of questions. Hey.
Yeah, we have a couple of questions in chat as well as.
Okay. Yes, we have awesome resources to for you to learn SQL. I will actually share some of them, and I'll post them. If you are following this on LinkedIn or on Tweet, you'll see recently we actually did an Azure SQL bootcamp. It happened actually last week, and all those videos are available on YouTube, and then you can see them. And in a bit, while Q&A happening, I'm going to post them on the chat window as well. So thank you. Good question.
Thanks, Sanjay. We have one more question.
Okay, one more question.
Okay. Bilal is asking, does Azure have a data warehouse solution in the cloud as well?
Yes, Azure does have a data warehouse solution, and if there is interest in the audience, we can have a session on that too. So it's called Azure Synapse or Azure SQL Data Warehouse, and that's an awesome product as well for building data warehouses in the cloud.
Great. Thanks, Sanjay.
Okay. Thank you. We will move on, and then I'll come back to other questions.
Okay, good.
Okay. Okay. So. Okay. So what happens in we talk all the examples we saw had one databases, but what if you have many databases? And let's say your one database usage pattern is like this. On the y-axis, think of it's how much you are using the database, and over a period of time. As you can imagine, all databases are not active all the time. Some databases spike, some databases stay low for a long time. And what would have happened here is that if you are provisioning this database, you will provision the database for the peak usage, because otherwise you will be resource constrained when it peaks, and you'll be paying for that kind of provisioning. So what if you have two databases? The second database, third database, fourth database, you have many databases. Everybody has their peak at different time. So instead of provisioning database for one database peak, you could provision them as a group of databases peaking to what level? Think of this if you have 20 databases. What this comes to as a conclusion that not all databases peak at the same time, and therefore you do not need to buy or spend money to buy a peak capacity for individual databases. You can put them a concept what we call is an elastic pool, and as a pool they can share resources, and each database will have their own reserved way to how much they can peak and how much minimum resources they can get. So that by you do a lot of cost of optimization, and that's we call it elastic pools. You can create a pool, and you can actually put many databases in the pool that you can have many pools. You have pool 1, you have pool 2. If this pool gets busy, you can actually move a database from pool 1 to pool 2. If let's say one database becomes very, very heavy hitter, and you say, it's not worth sharing its resources with everybody else, you can move this database out into its own, give its own resources. Or you can say that, I just created a database. I don't think this will be needing its own resource boundaries. I can share it with others. So let me put it into a pool. So doing this can be done online, either through our portal or through any of these APIs that you can make use of. It's very easy, very simple, and very dynamic. So that gives you the flexibility of creating databases and having a friction-free experience of moving them across pools, between pools, from non-pool to pool, from pool to singleton. That's a awesome capability when you are dealing with lots of databases. We have customers who have 250,000 databases, 100,000 databases. So you can imagine the amount of databases they deal with. Okay, given this database so powerful, the demands on this database is continuously increasing, continuously coming up with new scenarios. So I'll talk today about two new innovations that have come in this space and share some insights into you. One is called serverless, one is called hyperscale. What is happening in the world today is that applications have varied usage pattern. We talked about the IoT application with a power meter. Just change that, similar application, but think of this as a weather application, which means is we have weather centers sending information to the database about what's the weather thing going on, whether it's cloudy, rainy, windy, etc. And then people use their weather app on the phone or wherever they want to use it, and then checking the weather. On a normal day, people maybe check their weather once and they're done. But on a stormy day, on a day when the weather is not so great, the usage may be unusually high. So how do you provision database capacity for this kind of stuff? If you provision for the peak workload for a stormy day, then on other days you are wasting resources. If you provision database for a average time, average resources, then when you have peak workload, they will suffer performance because not enough resources. So how do you optimize these two scenarios? So what we have come up with something called Azure SQL Serverless, where the database can scale by itself, pause by itself, resume by itself, as if it has its own life. And thereby, you pay only for the usage that you do it. For example, when the usage increases, it will scale itself up automatically. When the usage decreases, it will scale itself down. And if you stay inactive for a period of time, it will pause the database. That means when it is paused, you are not being charged for the compute. You are only charged for the storage of the database, which is very, very cheap. And then when you have people start connecting to the database again, it will wake up, which is called auto resume, and then it will start scaling as the need comes. Very cost effective, and you actually do a per second billing, which makes it even more cost effective. And then if you have a database or an application where your usage pattern varies, this is an awesome choice. And again, this is a fully managed bus. All these things that we talked about, high availability, backup, restore, patching, upgrades, redundancy, everything is built into this. Give an example of the portal. Left side, you see when the database is being used, there is spiky usage for this database in last 24 hours. On the right side, when it was built, the bars represent the time periods when it was built, what is built. So when the database was used, is being built. I'll click on a time period when the database was not in use, for example, this time period here, and you can see that database is not in use, and therefore there is no bill for the database. So that's the benefit of a serverless database. Moving on to the next thing called Azure SQL Database Hyperscale. You saw we are ingesting millions of rows per second for the IoT database. And with this kind of workload, the data volume increases very, very fast. When the data volume increases very, very fast, you need to manage very large databases. What happens is that very large database is that sometimes the data volumes grow, sometimes the compute need grows, and they can grow independently. Earlier, what used to happen is that all the database, a given database was in a given box. By box, I mean it could be a physical box, it could be a VM, it could be container, whatever is. Box means a set of boundaries. You cannot split the database outside it to give it, either if you need more CPU or if you need to give it more memory, you could not do that because everything was boxed. It was one engine that was running. What we have done is that we have designed a database for the cloud where we have come up with a new database form factor called SQL Hyperscale, where you can scale the data volume to 100 terabytes, and independently you can scale the compute as your need grows. You could have a 1 terabyte database with 80 cores, or you can have a 100 terabyte database with just 5 cores or 10 cores. It's all possible because you can do that independently. And how we do that? What we have done is that we have taken one SQL Server engine and split it into modern design for cloud into multiple microservices. And one of the microservices is called compute. That's where users connect. That's where it's a stateless service, but it is a local SSD cache of all the recently used data. If you're familiar with SQL, you know there is a buffer pool. In addition to the buffer pool, what we also have something, a local SSD cache. The buffer pool is in the memory. To support the buffer pool, we have something called Resilient Buffer Pool Extension, RBPEX. And that's also on this machine. That caches recently used data and thereby gives a fast service to the users who are connecting to it. This is the same SQL engine that did everything for you before. So for a user, nothing changed. The log is put in a separate microservice called log service, which is a local SSD cache for very fast performance. And it has also got Azure premium storage to give you high log throughput. And every transaction it goes to the log service, and then you can read from the log for transactional consistency. Now, whatever data cannot fit into this local cache is fit into a set of page servers, which is also a set of machines with humongous amount of SSD in them. So if you had a 100 terabyte database, we will pull in a set of machines to actually cache 100 terabytes of the database in local SSD to give you super fast performance. So this gives you the independent growth of compute and storage, as well as independent scaling of them, as well as the best of performance. And then there is the durable storage, which is the Azure storage. This is for the durability of the data. This is put into the files into the storage format. So this gives you the flexibility as well as the agility to be able to grow your database. Guess what? We also provide multiple copies of the compute. One compute is read-write, and you can have multiple copies of that for read-only access too. So this gives you, if you have to run read queries in conjunction when you have read-write going on your primary compute. What I want to talk next is actually the challenges that these big databases bring in. Big databases bring in big challenges. How do I back up my big database? How do I do transaction on my big databases? I'm going to give you a demo of a big database because this will be much more easy to understand in a demo. What I will show you is in a big database, people do make mistakes. Big database, small database, databases do not differentiate when people make mistakes. There are possibilities when people do a transaction without a where clause. You may have seen it. Sometimes people run a delete without knowing it. You need to be able to recover from these things fast. I'm just executing something here I'll explain what I'm doing. I need to execute this so that we can go on. Okay, so what I have here is actually two copies of the same database. Same data stored in two separate databases, the same copy. The database are very big, 13 terabytes in size, as you can see. And I have a table there which is called store returns. It is 20 billion rows in them. The difference is that on one database, I have this particular feature called is accelerated database recovery turned on and is set to 0. That means this is not turned on here. On another, the second one, I have it turned on. This makes a difference in case of recovering from silly user errors. And here I'm going to show you what kind of silly user error I have done here. I want to run it for a few seconds for you to be able to see the impact of it. What actually I have done is I have a transaction, and that transaction, I have accidentally commented out my where clause. People make such mistakes. They may have been testing this with a test database and then change their connection to the production database, which is much bigger. and accidentally executed the query. And they realized a few minutes later, oh, what did I do? I must cancel my queries. I need to roll back this transaction because this is not what I wanted. So they go cancel the query. And you can see this is a database which is 13 terabytes in size. This table is pretty big. This table is 20 billion rows. So this update has gone further in its lifetime. And what it needs to do is that rolling back, it takes a lot of effort. So it is doing rollback, but it will take a few minutes to do that. On the other hand, on my right side, at the same time, I did the same mistake. I had the where clause here, and actually what I meant was this where clause to be commented out. But guess what? If I was running this with or without the where clause, and I was running it for a longer time, and I cancel it, it cancels instantaneously. The difference is actually in this feature. This actually allows the database to recover from these kind of user errors instantaneously. Making mistakes is our birthright. We can make mistakes and we learn from them. So developers of the world, go make mistakes because the database is taking care of your mistakes. Now you can cancel the query fast. You want to comment or uncomment out the where clause, and then you can go about your business fast. Your progress on your development cycle is not restricted by how fast the database can recover. This will take a while. Even though it was only 1.5 minutes by the time we killed it, it will take a while to come back. In fact, this capability that we are talking about here, accelerated database recovery on, is turned on by default on all Azure SQL databases. I talked about we have more than 6 million databases running all over the world. It's turned on all of them. So you cannot actually go turn off like I did here. This is one of our test servers I have to take to show you a demo. In fact, all databases this is turned on. So you go to Azure SQL Database, you make these kind of mistakes. Don't worry, we have you covered. You can cancel the query and it will be very, very fast. So that's about the hyperscale database. And this is actually the diagram that describes how this recovery is happening. In the interest of time, I'll leave it for you to digest. We have actually written many white papers on this topic as well. On closing, what I would like to show you is that we have Azure SQL is actually a family of products. We have platform as a service and we have infrastructure as a service. And we have basically 3 offerings. You can have a database. What I showed you is actually a database. You can have a full instance to yourself. You know that SQL comes with an instance model, and you can have an instance. You can have instance-specific capabilities enabled on them, like cross-database queries. And then if you want to have full control, for example, you want to run SQL Server, specific version, specific patch, because that's what your application needs. Then you can run it on a virtual machine. That's called infrastructure as a service. And no matter what you choose, you are picking the industry-leading database with the best security, best compliance, and best price performance. And today, what you saw today is the green box with the Azure SQL Database. With that, I will take more questions, and you can reach me on Twitter, through my email if you need. I'll see if there are questions. Are there more questions today?
Yeah, Sanjay, we have more questions. We can take 1 or 2 since we have 3 minutes left for the session. If there are any left questions, then we'll take the answers offline and we'll be posting it on our Slack channel. I have shared the Slack invitation link in the chat. And let's start with the questions. So I see a few questions in the chat window. Okay, our first question is, so Microsoft SQL is a flavor of relational databases. Is it not a managed service that allows you to run any relational DB like Postgres?
Very good question. So Azure provides you multiple database choices. What I showed you today is a Microsoft SQL Server's managed service, which is called Azure SQL Database. Azure also provides managed service for many open source databases as well, like MySQL, Postgres, MariaDB, and their name is called Azure Database for MySQL, Azure Database for PostgreSQL, Azure Database for MariaDB, and that way you can avail an open source managed service from Azure.
Cool. Thank you so much, Sanjay. Let's go ahead with the next question. So next question is from me. Uh, what's the best way to gauge which is the type of database that's needed for my use case? So like, depending on the use case, how do you decide which one would be the best type of resource or best type of database?
So as I showed you, the high power of Azure SQL Database, high flexibility, very awesome cost control that you can have. You can go serverless, you can pack them in a pool, you can do all this kind of stuff. You are guaranteed to go no wrong if you pick up Azure SQL Database. It has got the whole power, all power of it, and it has got all the flexibilities of it. Many times people think that, oh, I'm getting into a database which is not open source, maybe expensive. It's actually not. In the cloud, the cost plays out so way that you may be actually paying less by picking up a proprietary service. You may be actually putting yourself in an advantage by picking up a mature service like Azure SQL Database, because your time to market will be fast. In this fast-moving world, new application developers, if they are able to bring their application, their product into the market fast, then they're ahead of it. You know, this 500 million applications will be developed, and there will be competition to who wins in that space, which means that those who can bring their application fast to the market, which means that they need a lot of sophisticated features, which Azure SQL Database provides, which you may not get in other databases. Because this is the most mature service. It has been there for 10 years. It's already serving from healthcare to bank to finance to insurance to gaming industries. So bring them in. You will go no wrong by using Azure SQL Database. Your application will be well served. So go for it.
Cool. Thanks, Sanjay. This is our last question. When would you choose SQL serverless over the traditional managed offering?
Okay. So SQL database of your managed offering. I believe the question is basically, if you're in the cloud, then you have two choices. Either the platform as a service, which is the managed service, which we talked about today. We also have the infrastructure as a service, which you can find as a useful, provided you want a specific kind of control. For example, if you want to have a specific version of the SQL Server, if you want to have a particular security patch that needs to be applied because your application needs it. If you want that kind of control, you know, the more control comes with more responsibility, which means that you will have to manage the patching of the databases. You have to manage the high availability of the databases. You have to design a disaster recovery solution for your solution. If you have to take on those responsibilities, then you may need a regular SQL Server running in a VM in an infrastructure as a service. If you don't have those needs, go for a managed service like Azure SQL Database.
Great. Thank you for answering the question, Sanjay, and thank you for your time and sharing.
Yeah, thank you for the opportunity. There was a awesome question at the beginning, how I can learn more. I actually put a YouTube playlist. This is a recording of our Azure SQL Bootcamp, which you will find very, very useful if you're a beginner trying to learn what Azure SQL space is.
Sure. There is one last question that was in Q&A. Sorry, I missed that before. Are there established benchmarks already published?
Yeah, so we have worked with third-party companies. There is a company called GigaOM, which has actually done benchmarks comparing us and some other cloud database providers. So, and let me see if I can find benchmarks, and I'll put it in the. Okay, I am. Yes. So let me post it here, and you can see here is that GigaHome has done a price performance comparison between us and other database providers, and you can see those benchmarks are for you to see the results.
Okay, thank you, Sanjay. Thanks again for your time. Thank you everyone for joining us, and register for our upcoming events as well. We have some awesome events coming up. Thanks again. Have a nice day.
Thank you all.
Thank you. Bye.